Welcome to the second module of Measurement and Research Methods. This week, we're covering the dimensional qualities of behavior and measures of behavior. Here are the learning objectives to be targeted during this module. You can also find these on D2L. Let's start out talking about behavior analysis as a science. Science can be approached inductively or deductively. In the case of deductive science, a theory is developed and then tested through data collection. In the case of inductive science, conclusions are drawn based on data that have been collected. Behavior analysis primarily follows the inductive model. Science evolves over time and is adaptive and self-correcting. In the inductive model, if data that are collected are not in alignment with existing theories or assumptions, those theories and assumptions must be further tested and ultimately adjusted or disregarded if they're found to be false. Johnston and Pennypacker state that experimentation is about control. As part of this course, you'll be developing component skills that you'll ultimately apply in order to write and execute an experimental thesis, if you're in the master's program, that is. Regardless of your program, you'll use skills learned in this class in order to design interventions and monitor the progress of your clients. How can you control the environment and your own data collection and intervention procedures such that you can believably determine the relation between your independent and dependent variables? The first goal is to clearly define your dependent variable in the first place, such that you can reliably and accurately measure it. The goals of our science are description, prediction, and control of behavior. You can find the basic definitions of these terms on the slide. Pause the video if you'd like to review them. Per Johnston and Pennypacker, description involves attaching a number to an event to distinguish it from other events. Prediction is possible when we're able to accurately determine the outcome of future measurement based on repeated past measurements. We'll discuss control during later modules when we get to the topic of experimental design. Cooper, Herod, and Heward note several arguments in favor of careful measurement by practitioners as well as researchers. Measurement helps practitioners optimize their effectiveness. It enables practitioners to verify the legitimacy of treatments touted as evidence-based, helps us be able to identify and end the use of treatments based on pseudoscience, fad, fashion, or ideology. It enables practitioners to be accountable to clients, consumers, employees, and society. And finally, it helps us achieve ethical standards. Ultimately, measurement helps us objectively evaluate whether our interventions are effective, and it makes that effectiveness more believable to others. Before beginning measurement, a target behavior must first be defined, as discussed in Module 1. This target, your response class, is your unit of analysis. The definition of your target behavior should lend itself to measurement of one or more of the dimensions to be discussed in this module. Behavior takes place across three broad dimensions noted here. These are the dimensional qualities of behavior. If I asked you to measure a tantrum, any or all of these properties might be relevant. How often does the client scream or fall to the ground? How long does each tantrum last? At what times of day do the tantrums occur relative to other events happening in the client's life? You might also want to know about the tantrum's form, e.g., the specific topography of individual responses in the activity we'd call a tantrum, or its magnitude, e.g., how loud the screams are. These are measures of behavior based on the dimensional quality of repeatability. Count is typically insufficient. We may know that a given behavior has occurred 10 times, but across what period of time? A measurement time of 30 minutes is much different than a full day. Even simply writing down the start time of when you begin counting and the end time of your observation allows for much more detailed information. Rate is easily the most common measure used in the field of behavior analysis. Cooper, Herron, and Heward note 6 rules and guidelines for the use of rate, which you'll be expected to abide by in this and future courses. In particular, rate is best applied to measuring free operants. Free operants are behaviors for which there is no constraint on rate. That is, the behavior's occurrence does not depend on the behavior of someone else, such as a teacher. If a learner can only answer a math question when the teacher has asked it out loud, the response is not a free operant. If the learner can write down the answers to many questions on a worksheet, that would be free operant responding. As discussed in Module 1, acceleration is a measure of count per time per time. For example, change in rate per minute across days or weeks. You may see some slightly different usages of the terms count versus frequency versus rate. In this course and most, but not all, other behavior analytic resources, you'll see frequency referred to as synonymous with rate. In statistics, however, the term frequency is more often used synonymously with count. Mervitz and Mervitz clarify in a 2016 article why this has come to be the case and state arguments in favor of frequency being used interchangeably with rate. If you're concerned about this ambiguity, which is absolutely fair, you can err on the side of simply using the terms rate and count. Duration is a measure based on the dimensional quality of temporal extent. When measuring duration, you might wish to know the full amount of time that the target behavior took up over the course of your observation, or you might wish to know how long each episode of the behavior lasted. The former case might be useful in determining how much a given target behavior competes with other behaviors intended to occur during a session or at school. For example, what is the total duration of time spent tantruming relative to the duration of an in-home session? Alternately, in the latter case, you could determine the length of each tantrum. Are they consistently a few minutes in duration, or do they vary from a minute to 30 minutes in length? These are measures based on the dimensional quality of temporal locus. Note that in the case of these measures, you'll be measuring a duration of time, but the duration of time between events rather than the duration of a behavior itself. For latency, you're assessing the length of time between the occurrence of an environmental event, for example, a teacher asking a question, and the occurrence of the target behavior, for example, the student answering the question. In the case of IRT, you're assessing the length of time between two instances of a target behavior, for example, the student writing the answer to questions on a worksheet. You may note that these measures are fairly similar. In fact, Johnson and Pennypacker call latency specifically event response latency in order to differentiate between the two. Note that IRT is directly related to the rate of response. As rate of response increases, the IRT between those responses decreases. Conversely, if rate of response is low, there will necessarily be a higher IRT between responses. While rate of response is typically expressed as either the number of responses over the total time of the observation or average to the rate of response per minute, IRT can give you even more information, the amount of time between each occurrence of the response. Next, we have derivative measures. These measures are not inherent to the behaviors being assessed, but are rather derived for applied purposes. Percentage, while frequently used, is typically not an ideal expression of measurement. Percentage typically represents accuracy of responding, but it's a dimensionless measure. If you divide 8 correct responses by 10 total opportunities, you get 80%, but you'll get the same percentage if you divide 80 correct responses by 100 total opportunities. How many correct responses versus incorrect responses were emitted, and over what period of time? It's impossible to determine count or rate of response based on a percentage. Be prepared to thoroughly defend your use of percentage as a measure of behavior if indeed you end up using it. Trials to criterion is typically used in conjunction with other measures of behavior, as direct measurement of some dimensional quality will be required to determine whether the standard level of performance, the goal, is met. This measurement is useful for determining the efficiency of different teaching methods. For example, did a client learn a set of terms and definitions in fewer trials using the SAFMETS method or traditional flashcards? It's also an excellent way to determine whether a client's behavior is exhibiting agility, sometimes described as learning to learn. For example, a decrease in time or trials required to learn each new target. Finally, we have definitional measures. As these dimensions of behavior are typically used to operationally define a target in the first place, they're not considered to be fundamental dimensional qualities of behavior. However, particularly in the case of magnitude, there are cases in which many different levels of responding would qualify as a given behavior, and a researcher or practitioner might be interested in how the behavior varies along that dimension. For example, if a client is learning to read out loud, the reading would presumably only be considered appropriate if a listener could easily hear it and the client was not shouting. But does the reader's volume fluctuate during reading, and would it be helpful to reduce those fluctuations? Note that magnitude can refer to either physical force or amplitude of volume. Another way to measure behavior is by the permanent products it creates. This is a useful measurement to employ when it would be difficult or impossible to observe the behavior as it happens. For example, if it's very infrequent, if it occurs in private, or if you must assess the behavior of many individuals simultaneously. You could assess a learner's accuracy of responding based on worksheets that they completed. But note that this would not allow you to determine their rate of response. In addition, common problems with measurement by permanent product include determining ownership, determining one-to-one correspondence, and lack of contact with the actual topographical variations. Let's continue with the example of assessing worksheet completion. Do we have good assurance that the target learner actually completed the worksheet versus another classmate? How many times did the learner erase and rewrite the answer to each question? Did the learner complete the responses independently or copy off of a classmate? You'll review the pros and cons of measurement by permanent product in the second half of Chapter 4 of Cooper, Herod, and Heward, assigned for Module 4. Now let's practice. Write in the appropriate measure for each upcoming scenario. A list of the different measures is here for reference. You want to evaluate a change in how many math problems are answered per minute over the course of a week. You want to know how many times Martin claps his hands during a 1-hour math class. You want to know the time between each instance of a student getting up out of their seat. You want to know how many drinks you ordered while out with friends. How loud does your client call his mother's name when he's standing next to her? Your client wants to improve her golf swing. You want to measure the time it takes for your learner to respond after a peer asks a question. Your client wants to measure the time it takes to run a mile. You're teaching how to make a sandwich and want to know how many lessons it takes until your learner can make one independently. You want to know the proportion of how many steps of making a sandwich your learner completed independently out of the total number of steps. And finally, temporal extent. Its only associated measure is duration. What we have covered in this module should begin to suggest criteria that your dependent variable should meet in order to be useful to research. For example, you should almost always choose rate as your measure over percentage, as it will show you more precisely how your target behavior has changed. Even if you're using a set number of discrete trials, using rate will give you information about speed and accuracy. If you're not using discrete trials, every percentage will have a different number of opportunities to divide by, and that information would be lost. Percentage also has a ceiling of 100%, whereas rate has no ceiling. Let's say you only give 10 opportunities to respond during a session in the form of discrete trials. You won't be able to determine if the performer can perform at a higher rate over a longer period of time. And again, if you measure accuracy alone, you won't have a way to measure their rate of response. Let's practice selecting dependent variables and measurement of them based on sensitivity. In this case, the general target for measurement remains the same, but the dimension that we measure absolutely matters. If we were to measure the duration of time spent salivating, we won't have useful information about whether a lot or a little salivation was elicited in the presence of the bell versus food. Dogs salivate to some extent most of the time, so just knowing that the subjects were salivating in general is not a very sensitive measure. On the other hand, knowing the total amount of salivation emitted would give us a lot more information. It would be even better to see the changes in how much salivation was emitted over time. Try an example on your own now. What dependent variable would you be measuring? Try to think of an insensitive measure of that dependent variable. What would a more sensitive measure be? In this case, Bridget wants to measure the effect of her intervention, clearing her throat and giving a disapproving look, on the student's disruptions. This could be defined in a variety of ways, but here's one example. An insensitive measure would be magnitude of the disruptions. It's not particularly useful to know that the volume of the student's disruptions decreased if they are in fact still occurring. Instead, rate would allow you to know exactly how many times the disruptions are detectably occurring per class. Here's one more to try on your own. What dependent variable needs to be measured? What is an insensitive way that could be measured? And finally, how could we measure this dependent variable more sensitively? Duration of Henry pedaling the bike each week wouldn't be a great choice, as his goal is to increase his daily level of activity, and this would not allow interpretation of how often that was actually happening. Measuring duration per day would be a little better, but without clear definition of how much pedaling has to take place, how fast he has to pedal, etc., he still might be using the bike simply by sitting on it half-heartedly pedaling slowly. In the case of the more sensitive measure here, you would also, of course, want to note the date of each workout. When it comes down to it, your dependent variable should suit the general needs of the experiment and measurement. We'll consider these points in greater detail in later modules, but they're worth thinking about now. Ultimately, as stated by Johnson and Pennypacker, the target behavior must be available to human observers in applied settings for adequate periods of time, which usually requires good visual contact. That's it for this module. Have a good class.